This is part 1 of a series of demos showing how to use HPC-09 v6 in daily production. Part 1 shows how the operator enters data for a production line. We then investigate the accurate temperature and strength predictions produced. The accurate predictions makes production planning, discrepancy detection and as much as 75% energy savings possible.
HPC-09 communicates wirelessly with a measurement station and with a control panel. Blue lights indicates cooling status, red lights indicates bed heating status. We are currently working on Project Airport 1 with project number 1001. The current slab has serial number 9901. The slab shows data entered by the operator. Select the concrete mix used for this production line. Select the slab type, hollow core, or solid. HD320 is casted with same mix as the registered HD200, so we dismiss the dialog. We want to cure the slab in 7 hours. Indicate that we want to register the enter data for the bed when we click the register button. HPC-09 even predicts ambient temperature for the curing period. We want high-resolution 3D data for predicted temperature and strength. These settings are remembered. For normal production, select status NOR, meaning normal, which means production statistics will be produced. We add no comment now, it can be added later if you want. HPC-09 is now performing an initial prediction based on operator, measured, and predicted input data, selected mix design, hollow core type, target strength, target curing time, and predicted ambient temperature. The predicted temperature will be shown as a blue graph. This is all the operator has to do. From now on, HPC-09 is remote controlled from the measurement stations. However, in this demo, we will control HPC-09 from the user interface. The tab shows initial and corrected curing data. Blue column shows data for the initial prediction. Initial calculated TS shows the necessary pouring temperature to meet our curing deadline of 7 hours. Maximum predicted temperature and time for middle top of the slab is also shown. Necessary pouring temperature TS equals 26.9 degrees centigrade for the predicted ambient temperature, the gray graph. Max temperature equals 51.7 after 6 hours and 40 minutes. Bed heating is not used for this curing. This is the predicted temperature development based on the input data. References middle top of slab approximately 5 meter from end of bed in casting direction. Red graph shows predicted temperature at middle bottom of slab. Yellow graph shows predicted temperature at middle center of slab. Blue graph shows predicted temperature at right and left top, often used as the lifting zones. White graph shows the maximum difference temperature should not exceed 20 degrees centigrade. This is a 3D view of the slab with color legend indicating the predicted temperatures at time when temperature is at its maximum. This is a 3D view of the slab with color legend indicating the predicted temperatures at time when temperature difference is at its maximum. This view helps detecting places of maximum temperature gradients which may develop cracks. This is the predicted strength development based on the input data. References middle top of the slab approximately 5 meter from end of bed in casting direction. Red graph shows predicted strength at middle bottom of the slab. Yellow graph shows predicted strength at middle center of the slab. Blue graph shows Predicted strength at right and left top, often used as the lifting zones. White graph shows the maximum difference strength across the slab. This is a 3D view of the slab, with color legend indicating the predicted strength at time when target strength is reached at middle top. This is a 3D view of the slab, with color legend indicating the predicted strengths at time when strength difference is at its maximum. This view helps detecting places of maximum strength gradients where cracks may develop. This view shows the in-out bed heat temperatures for each bed. Large variations indicates insufficient heat capacity when additional beds are started. Large difference between in-out temperature indicates too low circulation velocity. This view shows the ambient temperatures at both ends of the production line. To optimize production capacity, the absolute variations should be as low as possible. Large difference between production line ends may indicate problems with compressive strength.
Thank you for watching part 1 in our demo series. Part 2 will show how HPC-09 performs a corrected prediction when HPC-09 V6 starts measuring the curing. For more information about HPC-09 V6, see www.objective.no.